Kind of. I think we've kind of done this before. All right. A linear inequality in two variables, such as x minus 3y is less than 6, is the result of replacing the equal sign in a linear equation with less than or equal to, greater than or equal to. A solution of an inequality in two variables, x and y, is an ordered pair that produces a true statement when the value of x and y are substituted into the inequality. For example, which ordered pair is not a solution of x minus 3y less than or equal to 6? And they give us certain ordered pairs there. We need to find out which of those is it for that does not work. Now, there's a couple of different ways you can handle this. The easiest way is to try and isolate which variable, x or y, when we're thinking about graphing. Y. So let's get y by itself by doing what? Yes. Add 3y to both sides. Okay. So x is now less than or equal to a 6 plus a 3y. Okay. Then what? Yes. X minus 6 less than or equal to 3y. Divide both sides by 3 is going to give us, equals y. Okay. Test 0, 0. Test 0, 0. Plug in 0 for x. 0 minus 6, negative 6, over 3 is what? Negative 2. Is negative 2 less than or equal to 0 for y? So this one works. Okay, that one's good. All right. Test 6, negative 1. Plug in 6 for x. 6 minus 6, 0. 0 over 3, okay, equals 0. Is 0 less than or equal to 0? Negative 1. So I think we found it. Let's check the other ones. 10 and 3. Plug in 10. 10 minus 6. 4/3. Okay. Is 4/3 less than or equal to 3?
Yes.
3 for y. So this one's good too, right? Question? No? And then negative 1, 2. So plug in negative 1. Negative 1 minus 6. Negative 7 over 3. Is that less than or equal to 2?
Yes.
Sure it is, because it's negative, right? This is the one that did not work. 6, negative 1. Because when I plugged in 6 for x, I ended up with 0 over 3, which equals 0. 0 less than or equal to y, which is, in this case, negative 1. 0 is not less than negative 1. Okay. So that's what we're going to be looking for when we solve these equations. Let's look at another one. Guided practice toward the bottom of the page on page 405. Negative x plus a 2y less than 8. let's rewrite so that we solve for y. That means when we plug in for x, it should make it easier to figure out. Okay, so in order to do this, what should I do here? Which is going to make the most sense? Raven. I could do that, or let's add x, okay? So now I've got 2y less than, let's go x plus 8, okay? Then what? Divide both sides by 2. So now y is less than x plus 8 over 2. Flip what? Why not? You want to keep 8 plus x? I'd rather do x plus 8. We can do that, right? Because we're adding. Same thing. It's more aesthetically pleasing, they say. Looks nicer. Okay? So let's test these three solutions. We've got 0, 0. We've got 0, 4. And we've got 3, 5. We need to find out which of those ordered pairs would fit or make sense. Yeah, go ahead. All right, so here we go. Let's test the first one. If we say y is 0, and we say 0 is less than 0 plus 8 over 2. Notice I just substituted my values for x and y into where x and y are in the equation. Now I'm going to do the work. 8 over 2 is what? Which is what? Is 0 less than 4. So this would be a solution. Because it works. Makes sense. Test the red. Now they say y is what? 4. Less than x is 0 over 2. 4 is less than 4. Not because it's missing that or equal, right? Or equal to. Okay, so that's a not. Over here, they say that y is 5, less than, that's 3 plus 8 over 2. What is 11 over 2? Is 5 less than 5.5? Sure it is. So another solution. Better? Sometimes you have to just, write the work out so you can see it. Otherwise, well, now we're going to graph. Okay. We're going to graph the inequality. Okay. How many points do you think are sufficient for us to get an accurate linear equation representation on your graph? How many points do you think? Let's do 3. Okay, so Mark, what values do you want to use for x? You don't want to use 0? Why can we do this? Why can we pick for x? What's the question, Raven? We're going to take this equation, and we're going to make a graph of it. Remember how we did that? We connected the dots, and then we put arrows on the end, and then we wrote the... Yeah, that's all we're doing right here. Okay? So, let's find out. Plug in 0 for x, and we get 0. 0 minus 3? 1, 4 minus 3. Put in 2, 8 minus 3. Yeah? No. I made this 1. So 4 times 1 is 4. Minus 3 is 1. Whatever I say x is, I got to multiply it by 4. And then subtract 3. Okay, good? One, two, three, four, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let's graph our first point. 0, negative 3. 0, negative 3. Right there. And 1, 1. And 2, 5. Okay. Once you get to that point, just put your pencil down. Then I'll make sure that we're ready to see something profound. Leah, is that pencil down? You're still right. All right, good. Now just put this on hold for a second. I just want you to watch with your eyes. What we're doing is we're graphing an inequality, just like we would do here. Now, when we would graph this inequality, we would show all the solutions to this inequality on a number line. So if it was just a regular greater than or less than, would we use a point or a force field? The circle, right? Because we said that what was not included. Right, because 6 is not greater than 6, right? That's why I put the circle. In what direction would I shade to show all the solutions that were greater than that? Remember that? And if I had an inequality that was x is less than or equal to negative 2, I graphed it just slightly different than I did the other. And I said, okay, if it's a less than or equal, I'm not using a force field. I'm putting the point on there because the point says that negative 2 is also a solution to that inequality. And then I'd shade and go to the left, right? Good. All right, so let's go back here. When I decide to graph, and it's just a less than or equal sign, a regular one, I'm going to connect these dots with the dotted line. Okay. The dotted line means that the points that lie on that particular line may not be actual solutions. Why? What do we come up with? Does this make sense? When we plugged in 1, right, for x, what do we get for y? Is 1 greater than 1? No. No. That's why that's not a particular solution, but it's going to help us make our line. Now, which side are we going to shade? Are we going to shade this part of our line or on this side of our line? Which is going to show all the solutions? Now, here's a hint for you. What is one of the more universal points on the coordinate grid that's very visible and very obvious? Yeah. The origin of 0, 0. So what we are going to do is we are going to test 0, 0, just like you did in the warm-up with the training wheels, remember? Now, if it works, then we will shade the portion of our coordinate grid that contains 0, 0. If it does not, we're not going to shade that part. So let's plug it in and let's test it out. Make it a 0. 4 times 0 is 0. Minus 3 is a minus 3. Y is 0. Is 0 greater than negative 3? Yes, it is. Therefore, I am going to shade that entire side. And the shading says that any point that falls along that is also going to be a solution to my inequality. Give me an example. Mark, see something over here? Something obvious? Sure. Negative 3, 1. So if we say x is negative 3, 4 times negative 3, negative 12 minus 3. Okay, so negative 15 over here, and a 1 is 1 greater than negative 15. You see what we just did? Earlier. Over where'd it go? Here. Do you get this shading? It's the same thing. Except we're shading on a graph. I drew a line. Right? Here's my dotted line. I connected the dots. And I've got either that side of the line or the other side of the line. You ever play that game? Like, you get mad at someone and they want to start a fight, and they go like this, and they say, okay, cross that line. And you stand there like this, waiting for you. Here's the line. Okay? You got two sides of that line. You're either going to stay here and be safe, or you're going to cross that line and get into it. Okay? Because 0, 0 worked in my inequality, made sense, right? Now I'm going to shade the part of my graph that has 0, 0. Okay? And you can't wait to try one on your own. Okay, so watch, stop talking and watch. What a concept. Plug in 0 plus 3 is 3. Plug in 1. 1 plus 3, 2 plus 3, 5. Here are my points. 0, 3, 1, 4, 2, 5. Okay? Are we good so far? Because it's just a regular greater than sign, I'm going to use a dotted line because that's going to say the points on the line are not a solution. So I'm going to connect these with a dotted line. And then it's very clear that 0, 0 falls on one side of that line. So I will test 0, 0 to find out whether or not 0, 0 is a solution to this inequality. When I plug in 0 for x, I get what? 0 plus 3 is 3. When I plug it in for y, I get what? Is 0 greater than 3? No. If the answer is no, I'm not including this as a solution. So I have to shade up here on that side of the line. 0, 0 does not work, therefore I cannot shade that part. Mark. Well, you only have another option with your line. It's either going to be dotted or it's going to be solid. Okay? So you use a solid. Okay, you want to try one more?
Yeah. It's not making no sense.
Y is less than or equal to x minus 2.